Hello, sir. So now we'll move to the third part of the video. So in this, what I'll show you is this structure. I should have it right here. So what I'll be showing you is first this structure, cadmium doped, the cadmium selenide structure doped with Fe, both Fe3 plus and Fe2 plus without the vacancy. So we'll look at how that structure looks, compare it to this doped structure that we have right here. So sorry, this one, the one with the vacancy. So we'll compare the doped structure, the cadmium selenide structure doped with iron without the vacancy, and then the one with the vacancy, both Fe2 plus and Fe3 plus, and see and from that I will prove to you, based upon how the charge density looks, that it is supposed to be Fe3 plus and not Fe2 plus. And this, as I mentioned before, this is a neutral cadmium selenide with the cadmium vacancy and Fe2 and Fe. So we don't know if it's Fe2 plus or Fe3 plus, because as I mentioned before, VASP decides where the charge is going to go when we put in the charge. Okay, and in this case, in the case of the neutral. So we'll go and look at this. Now, let me also mention, I don't know if I had mentioned in the previous videos, that in the Zunga paper, as you had told me, they were using gray and white. Now, I have used gray and white over here, but just to make the visualization clear, I'm using the brown and the white. So brown, as I should have shown before, is a cadmium, and the white is for the selenium. So now we'll go to this structure, Fe2 plus, which is, yeah. So I have this is the Fe3 plus doped in cadmium selenide doped with Fe2 plus and Fe3 plus, and this is the one with Fe2 plus. You can see it written over here, Fe2 plus, and this one, it's Fe3 plus. So right away, now let's just look at those charge density plots. So this is the Fe3 plus. Look at it, and now we'll look at Fe2 plus, and by looking at it, you will see a lot of differences in way how the charge density is distributed. So we'll look at Fe2 plus. Right away, you're seeing that there is a huge difference on how the charge density is distributed, specifically in terms of the radius. So if you see, look around over here, you won't see much change in the charge density on the atoms around the Fe2 plus. But when we look at Fe3 plus, you see that there is this charge distribution around here. Cause we are not looking at it as yet, because our purpose is to show that we have Fe2 plus in the case of cadmium selenide Fe3 plus in case of cadmium selenide that is doped with both iron and the cadmium vacancy. So since that being the purpose, we'll stick to that. So now let's look inside. So here you see the blue region, that means the charge is less in the doped structure, and when it comes to, and the radius is also big, and when we come to the iron, so the iron is right here. That's another thing. So iron is right here. I probably did not mention that earlier. So iron is right here. Let me remove the, so since this is a blue surface, so let me just keep it positive, so we should be able to see it. So when I just keep it positive, you see the iron right here. Okay. Click something else, so now you can see the iron right here. So that is iron substitution, exactly the same thing that we had seen with the in the postcard file. So if you look in the postcard file, we have the iron right here, the cadmium vacancy right here. So this right now is without the cadmium vacancy, so there is cadmium right here. So this is, so we're looking at Fe3 plus. So here we have that, as you see, this is how the increase in the charge around the iron looks like in case of Fe3 plus. So that means this is not a charge, okay. And when I'm saying it's Fe3 plus, literally this is charged system because we have removed one electron. So we have removed one electron from here, and this is how the structure looks like. So we're assuming that what we have in here is Fe3+. Now, in the next case, that is, okay, and now in the case of Fe2+, here, again, one of the main differences, as you see, one, that the radius of the charge, the radius in which you see the difference in the charge densities around the ion, that's actually very small, or I would say, yeah, it's very small compared to Fe3+. See, it's, in this case, it goes all the way around to these atoms. So the radius is this big, or yeah, for even the slightest change. While in the case of Fe2+, or the neutral structure, it is not all the way out to the extreme. Now, so then we'll look at the blue regions, that is where the charge is decreased, that is the selenium atoms around it. So in the selenium atoms around it, unlike the Fe3+ case or the charged case, we see that this is actually very small. There's not much of a change. And then when we look at just the surrounding the iron, that is right here, where we have an increase in the charge. So if you look at that, just the positive, okay. So we see, now this is a little bit different, okay. This is a little bit different than what we have for this case. So let's set this also to just positive. So here we see, just focus on the difference. You see the difference between these two. It's in terms of the radius. I don't know if it's obvious in terms of radius, how big or small. Okay. We can't state exactly in terms of this, but slight difference, but it's slightly smaller. But just to show you that these two are different, specifically when it comes to the positive areas surrounding it. Now, in the next video, we'll be looking at the combination of both Fe2+ and Fe3+. That is, we'll have, the combination of both the ion and the vacancy. So this is the structure that we'll be looking at in the next video. I'm cutting it short because of the size of the videos that I can upload.